Evening, everyone. I'm Pri, a tech lead at Crunchr, and in short, what we do at Crunchr is crunch HR data. It's in the name, meaning that we help specifically larger companies with all their human resources problems. They can vary from like what people are leaving the company at this moment. Yes, sorry. So we are trying to solve problems for human resources departments, ranging from what people are currently leaving the company, in what regions are they leaving most, am I doing well within this department, etc. So in short, we try to give insights to HR departments from their data so that they can make data-driven decisions. Usually, larger companies already have lots of HR systems, ranging from talent management systems to payroll systems, etc. But what they usually lack is having one system where they can actually take a look at the data from all of these together. So what Crunchr tries to do is we consolidate the data, validate it, and make it available to end users in an easy way. What makes us unique compared to some other products is that very often these data warehousing tooling systems look like this. So there's lots of data fields, menus. It's purely focused on the correctness of the data for this. And what Crunchr tries to do is to give this data back to the end users, to the HR community in a simple way. So that might start off with some easy metrics. For instance, what's the average age of the company? What's the current headcount? And then we can also zoom in into these metrics. Where are the largest changes going on in the company? Ranging also from metrics to nicer visualizations to make it more understandable, to be able to present it in a boardroom. And one powerful feature that will also be covered in our tech presentation by Daniel and Vasilis is the global filter. This sidebar here on the left will make sure that any analysis that Crunchr can do can be filtered on in any kind of dimension of the data that's available by the client. We built this and we also started in around 2014. And currently these are the most prominent technologies that we are using. Yeah, without further ado, I'd like to give the stage to my colleagues, Vasilis and Daniel.
Yep, as they set up, please continue. As they set up, just a quick overview for tonight. First is Crunchr, Daniel, Vasilis, and then a 5-minute break to get a beer. And then Tiqets takes over with Maarten and Bernardo, and then room for more beers. Enjoy.
Give us a second. This is part of the presentation. Okay, so hello everyone. Allow us to introduce ourselves. I'm Vasilis Hadjipanos. I'm a software engineer working at Crunchr for the last 3 years, and I work mostly at frontend. And
my name is Daniel Bradburn, also a software engineer at Crunchr. I'm working mostly on issues related to scalability, performance, robustness of the application. So our talk this evening is titled "How we went from caching to lazy loading," and the short answer is with a lot of blood, sweat, and tears. But let's dive a little bit deeper. So you saw some images of Crunchr from Pri. I want to give you a little bit of a demo just to give you a bit of context about what it is that we're talking about here. I'm going to be focusing specifically on the filter here. So we call this the global filter, and it really does act globally. So for example, if I was to filter on a location, some locations that say Amsterdam and Utrecht, if I go to another page, this is probably easier to see here, we can see that filter is applied here. So it's really at the core of our product, both functionally and technically. Because it's applied globally, the state of this filter is sent to the backend with every request. And I think it's also important to note that this talk is really about a redesign, a refactoring of this particular part of the application. The way that it used to work previously was that it was very tied to the life cycle of the application. So the application wouldn't even start until it had loaded this data. Another important point to mention is that this data is dynamic. It changes per client, so it's not static. We have to fill it from an API endpoint. And it's also tied to the authorization of a user. So for example, if I was to log out and log back in again as a different user, I was just logged in as Alice. Now I'm logged in as an admin. We can see the actual data that fills this filter is different. So it's very, very dynamic. So I told you it was filled with an API endpoint, and this is what the response used to look like. So this is JSON. Here we have location, the location dimension. We can see the IDs, the labels, and the hierarchical structure that we just saw. JSON here. We also send the current selection to the backend with every request, and that's how that looks in JSON. So we have the key, which is the filter option, and then a big list of IDs. In this particular case, the ID 17 is Europe, Netherlands, and 18, 19, 20, 21 is the children of the Netherlands. So what you see here is a user probably clicked the Netherlands, and we include in this list all the children and all the indirect descendants as well. So imagine there would be another level, then they would also be included in this list. So for very large hierarchies, this can become quite a large representation. That first response that I showed you, the big blob of data, this graph represents the problems that we were having with that. So this is the response time against the size of data. So we see here for the smaller clients, it's within 5 seconds. Pretty slow, but it's kind of acceptable for our use case. But when we get to the larger clients, we see here 25 seconds just to load the application. It's just not acceptable. So we need to do something about this. And in fact, we had one customer where it was taking so long that they're getting a timeout. So it became a real emergency. We needed to do something fast. So we have a Jira issue here. We decided that the easiest and simplest solution to this problem to give us immediate value to the clients was to pre-compute the response that we see. So we figured that has to happen for every authorization change, every version change, but we figured it was manageable. And then we take a look again at the new response times, under 350 milliseconds from 25 milliseconds. So that's a pretty nice speed up. However, we started getting bug reports, and lots of them. And there was so many edge cases that we hadn't factored into, and so flaky that this was just a ticking time bomb. Besides that, the application itself was also a little bit clunky when we're talking about these large hierarchies. What we see here on the left is the response time for a click event. So when somebody clicks on a multi-select item, the time that it takes before they see a response for that on the screen. So here, 400 milliseconds for the 36,000 node hierarchy. That's just too slow. We're also seeing that the response size was really, really large. So to send 6 megabytes of data just to load the application is not exactly mobile friendly. So we had this problem that pervaded through the entire stack. We had problems in the back end, the computation time to actually calculate all these responses, and the amount of space required to store them was pretty unworkable. We also had problems on our API layer. So the response size for the initial data load, as we just saw, was really big. And actually working with Crunchr, when you're filtering, you have to send the representation back. And when we have this big full list representation, it's, again, just way too much data going back and forth. We also had some problems in the front end. So the multi-select component that we saw there in the filter, it was really tightly coupled to the API, and it had a lot of business logic and rendering logic all in one component, and it was also hurting the interaction times. So what did we do? We decided to grab the whole bull by the horns and completely redesign the whole system. So we felt that lazy loading was the correct approach to this big blob of data, that we only fetch what we need as it should be rendered. Excuse me. And that when we have a selection, that we should use a more compact representation rather than sending the full list every time. And we call that allow deny. So this is going to tell you a little bit more about how that works. When we use lazy loading, we don't have to do any pre-computation in the backend. So we managed to get rid of a load of computation and storage in the cache. And we decided to split up the service layer and the component. So we made this component that was way too clever, had way too much logic in it. We made the component all about rendering and user interaction, and communicating with the API and storing an application state was held in the service layer. So I'm going to hand over now to Vasilis, who's going to dive a little bit deeper into the technical details of what it was that we did.
Thanks, Daniel. As the title of the presentation says, we are moved from caching to lazy loading the application state. Actually, to achieve this, we basically redesigned the whole filter mechanism from backend to frontend. Because of the nature of this talk, we're going to focus more on the frontend part, and namely how we change the components while also migrating from an old framework to a new framework, how we actually separated and make the component only responsible for rendering, and which component took the responsibility of modeling the actual filter that is then sent with every request. Sounds too much, but we'll see. By the way, because it's the front-end talk, we used Reveal.js. That's one of the key learnings. Don't use Reveal.js. Use PowerPoint. Okay, so so as we said, the front-end and actually the hierarchical filters do not know about the hierarchy. They do not know about the full hierarchy. This comes with a set of assumptions that we are going to enumerate, and we find out why this change was harder than expected, how and if it improved performance, just to let you know how to design an application state in the future. So this basically shows the two paradigms, the previous one and the new one. The previous one, the full hierarchy is in the front end. The new one, the hierarchy is lazy. The best way, I think, to showcase both is to check what is the functional set that the filtering, the hierarchical filter support. So this is the filter, as shown by Daniel previously. It can render a tree, render a hierarchical. It can render a tree selection. So now engineering is part of the filter. You can select a node. The multi-select knows how to build a selection from this interaction. You can select all nodes. It's not really a filter, but you can do it. You can select none of the nodes, which basically removes the filter. You can search through the tree, which is again something that when the front-end knows about everything, this can be done in the front-end. The interaction is synchronous, is really fast, and this component knows how to do it by itself. You can search and select all, which is a more composite function. You can search and select none. Let's see this GIF just to make a bit more sense. So you first select everything, and then you search for engineering. Anything that passes the filter and is rendered, it's available, you select none, and that is removed. Again, something that's only possible because the frontend knows everything. And another thing that this component can do is it can render a label, which tries to describe what the filter is. And also it can show how many elements are selected. So before we move on, what happened to this set of functions and where did they move in the new case? Let's check technically how the previous component was implemented. The previous case was implemented in AngularJS. Anyone familiar with this framework can see the root scope references. Basically, this is a global object. This is a component, it receives options. This holds the full hierarchy as presented in the JSON format by Daniel, which is one of the points. The view model that represents the hierarchy was the same exact model that represented the hierarchy as an application state model, right? And the same stands for the selection. This is a two-way binded list which represents the selection sent to the backend, and it also matches the view model. So this sounds like a lot of technical terms, but anyone that knows AngularJS knows that if I change a huge object that's exposed to the view, and if I change that object from everywhere in the application, this will re-render. This by itself was horrible design, so we needed to get rid of it. And this is the new lazy select. This is how we call it. We like lazy. So it looks almost the same. The main big difference is that previously, first off, this is an Angular component. You see the brackets and the weird banana boxes and things. Again, this is an input element. So the component receives that resource, which now is not an object that matches the API, but a class that's an instance of this class which tries to take some of the responsibility from lazy select and put it in itself. And the selection is not modeled by a list of IDs, but again by an instance of a class. It's called hierarchy selection, and we'll talk more about it in a bit, hopefully. But yeah, that's the current technical case. None of these objects is a huge object. Both are just instances. Whenever these change, they are only checked by reference. You don't check anything by value. Now I will try to give some background on why we need to make this change. So what happens when you have model and view modeling for you? They are exactly the same. When you need to render multiple renders of the same exact thing, you probably will end up duplicating objects. And if these objects are dictionaries with 36,000 elements, this stops being scalable really fast. So the hierarchy resource. As I said previously, these models, this takes the place of the options. So what does it do? Basically, it abstracts away from the component, the whole hierarchy model as an application entity, and it offers to the component that wants to render a hierarchy just one method, one async method, which is called getDepthFirstValues, which is just a traversal. We don't really care about this. It's just a traversal of a tree. It should be enough for anyone that wants to render a tree to get a traversal and render just a list, right? So one interesting point, and the reason why we added this slide is that, yeah, this component, this class, took the hierarchy model out of the multi-select, but it didn't take the expanded state. As we can see, and because we need to support multiple different renderers, we have to make sure that any part of the model that's really tied to the view should remain there. So this is okay, important. The hierarchy selection, the second part of the responsibility removal from the multi-select, abstracts away the hierarchy selection, the list of IDs. It exposes methods to change the selection, which means that the component is not the one that will manipulate lists and do these things, just delegate an event to somebody else. And it exports to JSON. This this model will directly be used by filtering API to be sent to the backend. So we glimpsed a bit of how the technical implementation looks. Now let's see where all the previous set of functions that lived in the multi-select component, where did they go? How the going from a full hierarchy in the front end to a lazy hierarchy in the front end, how did it impact the set of functions? Rendering the tree remained in the front end. Rendering the tree selection also remained in the front end. Selecting everything remained in the front end. We can't select everything even if we don't know everything. Select none, again remained in the front end. Search through the tree had to be moved to the back end. One of the assumptions one of the functions that was based on the assumption that the front end knows everything. Second thing, search and select all, search select none. And these two last things ended up nowhere. This is a very important part because the only reason why we had these functionalities was because the front end knew everything. Now we cannot yet support this we cannot support this functionality. This caused a regression. So we haven't yet dealt with it fully, but let's see. As a second step, we would like to show how easy it is to design a component that renders a lazy hierarchy. Most of us have dealt with lazy lists. Usually it's very usual in any application to scroll through and load things on demand. Loading lazy hierarchies or rendering lazy hierarchies has some more problems. The guide we use to find out what we need to optimize, which experience we need to optimize for, is that we're trying to find out exactly how the user uses hierarchical filter. What's the main purpose? Is the main purpose to browse and explore a hierarchy? We don't think so. I think the main purpose of a filter is to be able to react to the selections pretty fast. The user wants to go there, wants to select Europe, and from that wants to next Netherlands and Amsterdam. It will not explore 36,000 nodes. So we're trying to focus on improving the performance of selecting rather than exploring. Let's see what we did to facilitate for a good enough rendering of a hierarchy. I don't know what this is. But exploring a hierarchy. So all these events that previously were pretty easy, all these events are synchronous, right? So scrolling means, okay, fetch from an object, what's the next? Okay, let's put it there. There on demand. Expand, collapse, all of these are synchronous. When you have to possibly lazy load something, when your whole interface is based on an async method, you have to somehow design an interaction that is synchronous, but also facilitates for the loading. So the best way, I think, to showcase how the component works is through some lifecycle examples. So when you, let's say, what happens when you expand a node? As we can see here, real estate children are not yet loaded to the front end. So when the user interacts, we immediately expand, we show loading, we call from all values. When they're back, we populate the view. Let's check what happens step by step. User expands Europe. We render 10 placeholder values. That's for lazy select. Then it asks the resource, 10 values that are children. Hierarchy resource has no children in the model of the application, in the hierarchies model. It loads 500 elements. 510 are just random values. They are not important. We just want to showcase that the view model will increase by 10 values, but the application model will increase by 500. Why? Because here we just want to optimize so that the viewport is filled. We don't care about anything else. But in this case, we want to minimize the calls to the backend. So it doesn't make sense to call 50, 50, 50 every time, right? So this is trying to be a bit smart and say, okay, given that the user tried to explore there, he probably wants to go around there. So that's why we showcase it as well. And this is a very important learning for us, the view model and the model difference. So we load 500, we return 10, and then the component replaces the placeholder values. Let's see another event, scrolling event. This is the best one to showcase exactly what I tried to say in the previous list of steps. If we let the GIF start from the beginning. Okay, so we scroll first. The first set of values, if you saw, rendered the loading, a placeholder value. Why? Because the hierarchy resource, the one that knows everything, hadn't yet fetched that. As soon as it fetched this 500, any other scrolling event was there available almost synchronously. You don't even see the loading, right? So again, an example. So let's go through the sequence pretty fast. User scrolls to the end, component checks, hey, are there any more values? If yes, it renders 10 placeholder, it asks the resource for 10. Resource doesn't have anything, it loads 500 values, returns 10, and then the component ends up replacing the placeholder values. So we saw that we took a hit when exploring a hierarchy, but we realized that we don't really care. We managed to design a good enough user experience to facilitate for the ones that want to click. One thing that we really wanted to make scalable and fast is selecting. So let's see what we did with this. So, and the best way to start describing how we changed everything is by introducing how we model a hierarchy selection now. Let's go over the facts. So the frontend does not know everything, which means that the representation that is a list of IDs that includes all the nodes of Europe cannot be supported anymore, right? And let's make an example. A company has thousands of offices, like Tiqets hopes to have, and in Europe it only has 1,000, right? So selecting Europe means that I create a list of 1,000 nodes. Again, this is not possible anymore. What would happen? How could we model the same exact selection in a more semantic heavy way to avoid manipulating this set of these lists? So this is an example of a hierarchy. Nothing is selected here. We have a global, we have some Europe nodes, we have a set of things. Let's say the user clicks Europe. Somewhere in the application model, the previous case can be seen here. These 6 elements that are included are present in the list. In the new scenario, we're just saying, hey, default, deny, but don't include anything. Allow Europe, and this means Europe and its subtree, and deny anything. Deny nothing. It even reads better. Even if you go and read it, you'll understand better what is selected. In order to understand here that Europe is selected, you have to know that it only includes Netherlands and Germany. So let's see what happens when, let's say the user wants to include only Germany. So he has selected Europe, and then he deselects Netherlands. He wants to remove it from the filter. Again, the list update here shows one by one of the nodes in the list. But the more semantic heavy representation says default deny, allow Europe, deny Netherlands. Before I make the last point, what would happen if I tried to deny China in this representation? Nothing would change, right? So now that I want to deny Amsterdam, though, I have to include in the allow list. As we can see, this representation is more semantic heavy. It offers some kind of encoding for free. We didn't really explore what it can do. We are here to say that dealing with this was extremely hard for us, very, very heavy algorithmically, but we really like the end result. We really like that we can communicate with the backend without sending thousands of things. So I think that's it. Everyone that has any questions, please ask in the end. We tried to not include too many technical details. So let's see, give the mic to Daniel so he can some takeaways.
Thanks for this. Okay, so I just want to wrap it up talking about some of the takeaways. I think it's nice to start with some of the things that we actually achieved with this redesign. So one of the big things is we reduced the initial payload size, right? We're not sending this big blob of data. We're just requesting it when on demand. So the initial payload size is much lower, and that varies depending on the size of the customer, which obviously has a big impact on the initial load times. One of the really nice things about this redesign was that we decoupled the component from the services. We really thought about where the responsibility for each piece of functionality should lie. And we ported a really large part of the application, a really core part of the application from AngularJS to Angular. And we created a lot of technical infrastructure, which we're hoping to use for new features. And importantly, this slide that I showed earlier with the response time for the multi-select versus the lazy multi-select. So previously, we had this real big scaling issue when you have 36,000 elements and you try and select one, you have to wait 400 milliseconds before you get some feedback on the screen. Now, with the other representation, you're not making a list of 36,000 elements anymore. You're just making a dictionary with a list of one element. So that's obviously going to be a constant regardless of how many nodes you have. So this was a really big UX improvement. We've also started to play around with the idea of this new functionality, things that just would have been completely impossible with this pre-computed big blob. So now we have the filter react to itself. So the filter can filter the filter, which is a little bit down the rabbit hole. Or we could have these filtered age distributions or the head count, some nice new functionality. And there's loads of things that are now possible now that we've done this refactoring. And then some takeaways. So when defining the front-end application state, we think it's important to optimize for the pixel bottleneck. So think about what can actually be rendered. Can we render 36,000 nodes? No. So we don't send 36,000 nodes. We only send what's rendered, and maybe a little bit extra for prefetching to improve the user experience. It's very important to think about the functional and technical requirements and infrastructure. So as Vasilis said, we had to think about what do we want to optimize for? Do we want to optimize for exploration or for selecting? And for us, selecting was really important. And we really gained a lot of benefit from separating the application state from the view model. Makes us a lot more agile, flexible. In terms of hierarchies themselves, it was a really hard problem, a lot harder than we thought when we first started this project. But it is possible. And we really like this compact representation. The examples that Vasilis showed maybe don't highlight just how much more compact it is, because there you have a list of maybe 10 elements compared to a dictionary with 8 elements, I think 5 elements. But when you're talking about nodes, hierarchies with 36,000 elements, it can make a huge difference. So that's our talk. Thanks very much for listening. If you have any questions. Actually, we have something kind of similar to that already, which does help a lot with a lot of these data questions that we have. But one of the big issues that we had with this specifically was the sheer size of the data blob that we were literally just sending. We might as well have just sent the entire database to the front end. Yeah, caching can help, but at the end of the day, it's just too much data. Front end doesn't need to know about it. Yeah, but I mean, like I say, we do have a similar thing in the back end, like a service layer that caches responses. So you see, the first time you ask a question it might be slow. The next time you ask it, like this. Yeah, it's a good question. That's actually one of the things we really wanted to hammer into to our workflow, is that when we make an endpoint in the backend, that we also write an open API specification for that. And that was actually probably the biggest part of our application now that has fully specified API is this global filter, which is really nice. We have a beautiful rendered documentation and things like that, and you can actually interactively play with it, which is also really. Yeah.
I think it's the nature of the problem. It's really not common to have a huge object that you want to update with every authorization data and version change, especially for a company that we might change authorization 3 times per week, release a new version and a minor release, maybe everything together 2 times per week, and the company makes a mistake. So in general, that part of the problem, plus that it's a filter, it's a hierarchical filter, it's not, again, really common. We didn't think, this is not the wheel, we didn't design the wheel, right? We steal ideas from everyone, but I think it's nice to present this problem as this, because I think it's a bit unique. It's a bit unique in our case. Oh, it's a really good question. Thank you. I hope I answered well now.
Further questions? We're here with. We want to talk to us about this problem, then grab a beer later. Yeah. Thank you.
Thank you, guys of Crunchr. We'll have about a 5-minute break for Bernardo and Martin to set up. Pick a beer, grab a maybe a cold slice of pizza. See you back here in 5.
There you go.
All right, so welcome. Also, yeah, we'll be talking about performance in the front end, our website. Last year we participated in a pay speed race organized by Google. Prize we won, and yeah, we'll explain a bit about how we actually managed to do that. So yeah. Yeah, obviously we didn't really sync well with Sitsu, who already explained a little bit about tickets and what we do. So I'll skip the first one. Yeah, tickets started late 2013. Summer 2014 is when we first launched our B2C platform, Tiqets.com. Oh, it feels like a long time ago. It is. Yeah, tech stack. Yeah, Python in the backend, Flask, micro framework. But in the front end, we use React, TypeScript, Sass, and Jinja. Jinja is a templating engine, comes with Flask. By now, well, I think in the beginning was about 50-50 desktop and mobile traffic. By now, it's way over 75% of our users that use mobile. And yeah, Tiqets is growing fast, and with that it also means that we're developers, also front-end developers. So a little bit about this contest that Google organized. It was focusing on e-commerce companies. 85 companies were invited by Google to participate. They were focusing on the Northern Europe region, focusing on mobile only. We had to, yeah, so they were actually testing 3 pages: home page, a category page, and a detail page. In our case, was the product page. They used Lighthouse to measure the initial performance of each page. Based on that, all the different companies that were competing were put into 3 different categories. Because our initial performance score was already pretty good, we were put in the highest category. Yeah, the contest took about 2 months. And yeah, the winners were based on the how much we improved on our initial score. So why does Google actually care about performance? I guess just like us, Google knows that Google wants to provide to their users, customers, the best search result they can, and they also know that websites that perform better convert better. So it's it's in Google's interest to show their users the best search results. Yeah, why is performance that important for tickets? Yeah, to remind ourselves of that today, or during preparing this presentation, because more and more people nowadays have access to smartphones. More and more people are traveling and want to go to museums and stuff. So yeah, like I just said in the beginning, when we started, was around 50% of our users that were using mobile. Now it's way over 75%. That means it's becoming more and more important for tickets to work on performance and to prioritize that. Bernardo, you're it.
Right. Hello. So yeah, well, one of the things that I guess before the race, it was a good thing that we already had going in tickets, is that we tried to pay at least a bit of attention to performance. For us, the performance might not necessarily be focused on while using the website the way, for example, as a Crunchr case, but it's more about like showing the content as fast as possible to the users with the least amount of data that they might need in order to use our product. But the thing is that for the purpose of the race and for the purpose in general, for anyone that wants to focus on performance, we felt like we learned that the effort on performance doesn't only focus on technical solutions. It's not only about the things that you can do in the code. It's not only about the configuration in the application or whatever. But as equally as important as this is, it's also about the effort of bringing the rest of the company into the mindset of performance. So essentially for stakeholders to know that a slow website is going to make for less conversions, that people is basically, especially our users that are on the go, that maybe they're consuming like roaming data and whatever. It's very important that we keep this mindset that performance is always important. It's not only for the purpose of a race that we want to win for whatever reason, but it's about the users. And sometimes the effort to bring that awareness to the rest of the company is actually as difficult, as challenging as it might be to actually implement some of the technical solutions. So I feel like we're not necessarily only going to talk about some technical things that we might have done, but also, for example, some of the presentations that one of our data scientists did a couple of months ago, well, maybe like a year ago, is a good anecdotal example of, she presented this piece of data that essentially said that for bidding on ads on Google, they take into account the performance of a website in order to reduce the cost of the ads. And the moment that she presented this information, we could notice days later that some of our stakeholders actually took interest in prioritizing the performance tasks that we had in the backlog, maybe for months or weeks before, weeks or months before. So that was a good signal that if we make the effort of like visualizing how performance can reduce costs or make us potentially make more money, then that's a good way to actually get the buy-in from the rest of the company. So yeah, I wanted to like emphasize the importance of those things. The other thing that I feel like we try to keep in mind, and I feel like it's maybe one of the biggest things that hopefully you can take away, is that whenever, as front-end developers especially, whenever you build something, you need to build a new feature, you need to make a technical decision, you always have to remember that the user experience should be on top, should be more important ultimately than the developer experience. And obviously I can only speak from what I can observe and my own experience, but sometimes we might make decisions on a technical level that actually are only there to help us as developers to make our lives easier without realizing that they might actually hurt the end user. And like I said, this is especially important in front end because sometimes some of these, for example, a third-party library that we might include to make our lives easier as front-end developers implementing a feature might actually be 1 megabyte extra of data that we're asking our users without them potentially even knowing that they need to pay for in order to use our product. So yeah, we shouldn't put the developer experience on top of the user experience. So yeah, I mentioned third-party libraries. That's one of the things that I think maybe it's one of the most obvious ways that any website can actually like easily go down in performance is just by including third-party libraries over reliance on third-party solutions. So normally we try in this mentality of user experience over developer experience, when it's time to actually consider including something from an external source, we ask these questions. It's like, okay, what is this library doing exactly? And is it perhaps doing more than what we actually need? Excuse me. One of the things I remember like a long time ago, one of the things that we needed to consider was this particular library for Facebook interaction or something. And we needed for one specific thing, but this library actually included features for way more stuff that we needed to. And that was a clear way for us to say, like, this is not for us because we're going to be wasting the user's resources by including something that they might not even use.
And also another example of that, like years ago, we were using Moment.js, a date library that I assume most of you are familiar with. We realized that by default, Moment.js comes with a bunch of local files for all the languages that they support. And we noticed that all these files ended up in our bundle.
Yeah.
So we had to make some tweaks to our Webpack configuration to only include the local files for the languages that we support. We'd even take it one step further to only load the file for the current active language. But yeah, that's just another example.
Right.
Should we also let Jarek ask his question? After.
After, please.
And the rest of you can ask when.
So yeah, so that's another anecdotal example of what we mean. And sometimes, like the example of moments, it's also about analyzing what the libraries are doing, because by default you get like this out of the box behavior that is going to work everywhere for you as a developer, so it makes your life easier, like I said. But with some configuration that we have to do some extra effort, which is ultimately our job, we end up making use of these tools anyway, while also not burdening the user with extra resources.
I just realized that Cherek is going to evaluate me tomorrow. It's Thursday. So Cherek, ask your question.
Yes.
Yeah, it is possible. It's called
Shaking, yeah. I mean, I guess the short answer is it depends, because it's also depending on the way that certain libraries were implemented. Maybe these particular modules that you're interested in might actually be tree shakeable, but there are possibly some other solutions that are not. So that's also part of like, what is this library doing, and trying to see if it's actually something that you should use. The same kind of question goes like, what's the size of the library? Of course, it's like you may compare bundle sizes in order to see like maybe if this solution is actually the same thing that I need and it's much smaller, then why wouldn't I use it? And ultimately, this is a very tricky question to answer. It's not an easy one to answer, because it's all about that effort, that extra effort from a developer point of view, from a resources point of view within a company, is maybe you can actually just build the solution that you need instead of trying to find a third party to solve this issue for you. And hopefully, if you go to in this route, the solution that you end up with is obviously specifically for your case, for your product, and that should mean that there's no waste around it, right? Like you're building it for exactly what the purpose that you need. Yeah, just to highlight some of the tools that we used in preparation for the race, and like I said, during the whole journey so far. Bundlephobia, maybe you've known about it, but it's like a very handy website that allows you to, when it's time to consider an NPM module, then you can easily see like, okay, what's the actual size when it's minified, when it's gzipped, and all that stuff. So it's a very handy, nice way to say, okay, I should compare different libraries and make a decision on top of it.
Yeah. We use Google Tag Manager to manage third-party tags or pixels. I remember I was confused at first because I called them pixels. But anyway, I think you guys know what I'm talking about. So at Tiqets, the front-end developers have been taking care of Tag Manager from the very beginning. And we actually realized during the closing ceremony of the PageSpeed race at Google that this is not very common. This was not the case at most other e-commerce companies that were also competing there. In many companies, it's marketeers who have access to Google Tag Manager and can add these third-party pixels to your website, which as a result, the payload of these pages increase and hurt the user.
So I feel like that's also something like I said, like it kind of gives us it seems like it gave those a bit of an advantage from the get-go, because you may make whatever efforts you might want in terms of performance for your website, but the moment that you give access to non-developers to include whatever scripts and whatever they want into the page, then it's out of your control, right? So it is a very good position to be in, where it's the front-end developers that actually get to analyze if the third-party tags that someone else wants to include through Google Tag Manager are actually going to be a burden in performance. And especially, we can also determine how and where and when to load them, right? Like on which triggers should we actually include these things, instead of just like putting them in every page or in every situation.
Yeah, so let's have a look at some of the performance wins that we did over the years. So again, this is something, these are performance wins we got before the race started. Like I mentioned earlier, we started Tiqets.com, or the first version of Tiqets.com was launched in 2014. 2015, we did our first performance benchmark. This was the era of jQuery, and when you were using jQuery, maybe you use jQuery plugins. So I remember we were actually only on mobile. We were using a jQuery plugin. I believe it was called Scroll Magic, which would, if the user scrolled down on our product page, it would like highlight the discounted price in a fancy animated way. This plugin was 200 kilobytes, which I didn't really pay attention to when I implemented it. That was me. But yeah, the benchmark clearly highlighted this, so just removed it. And no fancy animation, but much faster website. Another example was on the homepage we were using, just for a short while, but still at the time of the benchmark, it was still there. We had some kind of fancy animation to explain to the users the process of tickets, what we do, mobile tickets, instant delivery, etc. But it was using CSS animations, heavy visuals, and yeah, not really benefiting the user at all. I think there was another 100, 150 kilobyte or something that we could remove. Yeah, another example is switching to image X. Thank you, Cherek. Static CDN image server, so CDN much faster, and HTTP2. Bernardo actually worked on lazy loading images on our website. Please do not use window.onScroll, which is very heavy. Maybe you don't know, but by now you can use intersection observer API instead. We also replaced our heavy icon fonts with SVG icons. And last year we put effort into moving our assets, CSS, JavaScript, also to CDN. Yeah, that benchmark last year also showed that our JavaScript bundles were way lower in size, sometimes 50% less. That was mainly because we split the bundles. So we have several, we have the B2C website, Tiqets.com, but we also have some B2B websites, portals. We realized that, but we only have one bundle. So just by splitting the bundles, we made the bundle that we serve to Tiqets.com a lot smaller. So again, like it's a lot of quick wins, but that actually, all these quick wins, these cumulative results actually make a big difference in the end. Yeah, let's show. Here's a nice graph of the total payload on mobile of the Tiqets.com website over the years. So the home page, the product page, checkout page, I only use those. So this was the result of removing heavy jQuery plugins and removing heavy animations. You can also see that the payload of the product page and checkout page actually increased, which is the result of adding features. Adding features to the product page. Our checkout also became a bit more complex over the years. But after that, you can see a pretty steep decrease again. It also shows constant struggle between product development and performance. Yeah.
Yeah, I'm sorry. I want to say, like, one of the things that we realized when we were looking at the graph is like you can see some of the things going up and then some of the things going down, and I feel like it's only natural that as you're building a product, you're building a website, you probably naturally have to add new features, and you keep adding new features, and then you can see these things like slowly, or maybe not so slowly, growing in size, in the size of the payloads to the client. But then, as you see, like maybe on this graph, when you make the effort into actually also thinking about performance, then it can go down again. But then naturally, you will keep on building new features on the product, and then it will go up again. So this is all related to the idea that with a shared performance mindset, then maybe it shouldn't be such a oscillating kind of movement. So yeah, like Martin said before, maybe some of the quick wins or some of the highlights that he showed you a couple of slides ago, we believe that helped us be in this first group of the high performing starting scores on the race. So just to remind you, during the race, the companies were separated into 3 different groups, and based on their initial performance score, they would put in like a low performing initial score, medium performance initial score, and high performance initial score. So the idea was that you wouldn't have to necessarily compete with a product that is already super performant from the beginning. So you're grouped together with the rest of similarly performing websites. And we like to think, thanks to these efforts that were made before, ended up in the high performing initial score category. But yeah, so once the race actually started, the first thing that we decided that maybe it's probably a very good idea is to have a central document where we can list all the tasks that we think are going to make a change, an impact on performance. And yeah, we decided to see like, okay, look at which metrics should it actually, do we focus on, which metrics do these tasks going to have an impact on which pages, what's the impact that we think is going to have, what's the effort that we have to make in order to make it happen. So the idea was to have everything in one place. So every week, every 2 weeks, I don't remember, we would meet together, like the group of developers that were put into the performance race. We would meet and look at this and see like what the progress has been, on which metrics should we focus on, should we actually focus on low effort tasks first, and all that kind of planning. So I think it's we started this for the race, but I think it's also like a very good starting point when you want to start doing something about performance, because it's a very nice way to basically start organized, right? Like you don't want to just have these tasks spread around without having like an overview of what could be the gains eventually, especially because, as you will see later, these tasks on their own might not seem like they made such a big impact, but as we will show as evidence, they add up, right? So it's actually a very good way to actually see in one place all the progress that you've made and how it actually reflects on the performance of the web. So another tool that we used, we actually did start using this tool for preparation for the race, is Calibre. It's basically doing web, specifically front-end related metrics and performance monitoring. The reason that we really like this one in particular is because, unlike some other alternatives, you don't need to put any script of theirs on your website in order to do the performance measurement. So they're on their own servers, their own devices, they're doing this test for you. And the good thing is that they're doing continuously, and they show you reports over time and everything. So this is also something that we think is really important, is that you should be able to easily see how your development of the product and your efforts in performance, how they're actually impacting the changes over time. If you don't have a way to see this, then it's also a very easy way to lose grasp of why you're doing this in the first place. Another tool, it's like a very manual labor in this case, but it's also something that was very easily told us some very big changes that we could do in order to do something about performance, is the coverage test from Chromium's DevTool. So essentially, you hit the record button, you start using your page, trying to switch on and on all the possible states of that page in order for it to see how much CSS and how much JavaScript you're actually using in that page in particular. And then as you can see down here, you get a report of like, okay, how much CSS is actually, for example, in this file, and how much of it is actually used or not. So we could see in this example in one of our pages that 95% of the CSS that we were sending was not used on this page. So, and that was, this is just obviously one example, but it was the case for the 3 pages that we submitted for the race, and other pages that were just as important anyway. So yeah, this was a very easy way to open our eyes about like, okay, we could do something about something that is not really that difficult, but we took for granted. And this is, like I said, a very easy way to see this. So yeah, we could see, you can also visually see like, okay, this was not used. So maybe this makes us realize that this is dead code, that this is never used, that it shouldn't be there. Or we can think about the strategies on when to actually request these styles if they're actually not needed. So by looking at that, one of the first actions that we took was just like, okay, let's think about how to get rid of waste on used CSS in this case. And it was a simple solution. I mean, the effective solution. We used to have a single CSS file, the one that you saw in the previous slide, that we were serving for every page on the website. And therefore, it included a lot of styles that none other page had to use. So we just said, okay, something relatively simple. Just let's have a commons CSS file, we decided to call it, that will have all the styles that are actually shared between pages. But then let's have another CSS file for each one of the different pages that we have. And this file will obviously only contain the styles that are used exclusively for that page. Doing this reduced the payload of our CSS for all the websites by more than 60%. And it was because of the nature of CSS, the way that CSS is render blocking by default, right? Like the moment that you request the CSS file from your HTML, the parsing stops until you have, the visual parsing stops until you have the whole file. It was a very, very effective way to get a lot of scores, points, because the amount of CSS that you had to download, the amount of CSS that the browser had to parse was much smaller, and therefore we could show content faster to the user. Yeah.
Another tool that we use to for bringing down our JavaScript bundles is the Webpack Bundle Analyzer. Yeah, just simply a matter of installing it, running it, and it will show all the JavaScript modules in your bundle, and yeah, it provides you with this visual representation. Yeah, the bigger the module, the bigger it is in file size. So it helped us a lot by identifying the big modules and yeah, which ones we should possibly consider taking out, or replace them with a smaller library. Yeah, so yeah, for example, underscore is a JavaScript utility library. I guess most of you are familiar with. Years ago, we replaced it with Lodash, which does pretty much the same thing, but it's a lot smaller. Now there's this also just utility library. So nowadays we are using that in some places, just that. The Webpack Bundle Analyzer also helped us spotting or realizing the size of a plugin we were using for our image carousel on our product page was quite big. So we actually replaced that with a smaller library. Yeah, something else that we did to reduce the JavaScript payload was to only polyfill the browser, only send the polyfill JavaScript to the browser that actually need it. So we don't send it, so it's not part of our JavaScript bundle anymore. PWO is something we used for, we were still using at the time for A/B testing. Yeah, how VWO works is you have to put not a snippet, but a script tag on the top of your, on the top of the head of every page. It's a blocking resource, so it will slow down every page by default. The JavaScript was loading was actually not that big, but still it was hurting the performance a little bit. So we'd actually known this for years, but we still want to do A/B testing, but participating in the space speed race also got the attention of a product development department when they came to realize this, and there were already plans for replacing VWO with something else, with an in-house solution. It actually helped us raising the priority of that, and yeah, so that actually allowed us to take out VWO and replace it with our own in-house developed A/B testing tool, because yeah, I guess the other reason for that is, we are a growing company. Part of that is that we are getting more and more data driven, and we want to be able to measure better the impact of our work, of the features that we are developing.
So something I want to add. I remember when this decision was made, and I feel like it's also a reflection of the company awareness. I mean, like Martin said, the ultimate decision to at least take VWO out at the moment that we did was because of the race, because we knew that it was going to be a big, meaningful change. But it ultimately it was a reflection of this idea that once you think about performance, then you might actually reconsider even some of the tools that you already were using, right? So in this case, we do want to do A/B tests. We want to make decisions based on data, but we also realized that the solution that we had chosen was actually pretty much just a burden for the users for our own benefit. And hopefully, and I'm very happy that we could make ultimately the stakeholders, the people that actually make this decision, because it's not only, in this case, it's obviously not only up to us as developers to say, let's not use VWO, right? Like, this is a decision that probably a bigger part of the company has to have a buy-in. So it's also the result of the efforts of company awareness when it comes to performance. So it's not necessarily like the actual act of removing these 2-3 lines of HTML from the page. That's not like a very challenging technical solution, but being able to do that as a result of the decision from a higher level, that's the challenging part in this case. And it's equally as important to make an effort in that.
Question. Yes.
All right, there we
go. Yeah, we actually found in practice that we were not using their tools a lot. We still required a lot of manual analysis by our data team. Also in the front end, at least, we were, yeah, we were also quite limited in sending additional data with events, for example. With VWO, you can trigger events, but you cannot send additional payload. The VWO's developers, maybe that's possible with OptimizeD, I don't know. But I remember with VWO, we actually had to do some sort of, we had to use a revenue goal. That's also an event, but you can send some additional payloads. Their developers advise us to use that if we want to send additional payload, for example, an event on the product page and we want to send a product ID, and it was suboptimal. So we were not using the graphs or the charts inside VWO. We actually had to download the detailed CSV that was sent to our data team, and it was, for us, it was not ideal. So now, yes. No, and I think, I still think they are both good tools, but maybe more for visual testing and not for the kind of test that we were running. Yeah, so, no.
Yeah, so I think this is the last highlight of the performance things that we did for the purpose of the race. So perceived performance. So a very, very concrete example was web fonts in particular. So we couldn't just, from a product point of view, we couldn't just say, okay, let's get rid of custom fonts or let's reduce the amount of custom fonts. But we could do something about it, which was all about, even though the payload is going to remain the same, you're going to still get the same amount of fonts. By doing this link pre-connect strategy, by connecting to, I mean, we're using Google Fonts, so by connecting to the Google Fonts domain earlier through the HTML, and also by using the font display swap property in the CSS, we can at least improve the loading performance of the web fonts that we were downloading. So that actually affected directly the first meaningful paint metric in the Lighthouse test. So it was all about, we're still downloading the same information, but because of the strategy of the improvements that we made here, we showed the meaningful content earlier, and that also improved and gave us some points as well. And again, I mean, yeah, this is a strictly technical one, but it's also not necessarily only about reducing the amount of CSS or whatever, but also about thinking of strategic ways to include it only when it's necessary or in a way that is more performant. So yes, in the end, this is the performance score throughout 2 months, almost, yeah, for the purpose of the race. We didn't do anything about the PWA score, which is also something that Google was looking into. But the main metric to look into was the Lighthouse performance score. And again, as in the previous graph that we showed you, you can see there during 2 months, we made some wins in performance, but then again, maybe a new feature was added that affected the score again. And then we fought back and so on. But ultimately, we managed to increase our Lighthouse performance score 10 points in total, I think, a bit more. And apparently that was enough to win the race against the rest of the companies.
That last jump is caused by, is explained by taking out the VWO script tag.
Right.
For the end.
Yes. So yeah, this is the day of that win.
A rare picture of me smiling.
Yeah, and it looks like golden medals, but it's actually chocolate, and I think it's from Heima. So I thought Google would do better, but at least the launch was good. And they also gave us Google Home
device.
Oh yeah, like a
Big
Google
Brother
speaker
device.
thingy.
Yeah.
but I have an open mind and I don't want to do, I don't hate anyone that much in order to give them that thingy. So it's still boxed somewhere.
That's Marcos, by the way, with these backends.
Oh yeah, it's a good one. So yeah, maybe it's actually worthwhile mentioning that obviously for the purpose of the talk, we talked about performance specific tasks, but one of the metrics that also was very relevant for the race and for performance in general is time to first byte, which is basically the time from the moment that the browser makes a request until they get the first data back from the server. And that is actually not something that the frontend can do much about because it's essentially optimizing database query calls or whatever backend stuff does in order to improve performance. So, and we did a lot of that as well. Like our backend developers also spend time doing that. I'm saying this because some of the backenders are here, so I don't want to leave them out. But yeah, it's also part of the effort, and that also helped us in the race as well. Like you also have to, it's not a front-end only thing. The backend also can help in performance of the browser apps. So yeah, the race is over. I mean, we were very happy that we won. They invited us there. They gave us nice lunch. They gave us a chocolate medal. But we felt like, okay, what can we actually take from this? Like during the not only during the race, but also afterwards. Some of the learnings or challenges that we thought that we should highlight. It's very hard to make like I said, I really emphasize it because it's actually one of the hardest things, more so than maybe sometimes more so than the technical solutions, is to keep the mentality of thinking about performance all the time. Maybe that's just us, but I do feel like it's talking to other people that were also participating in the race. Maybe some of them, they actually didn't even have the resources given by their companies in order to do something about performance. And yeah, that's also like an unfortunate reality for a lot of companies, right? But I do feel like if you don't keep this effort into like keeping the mentality, like we should always pay attention to performance, we should always think about what can we do, even if it's a small thing every time, then eventually it's going to just fall down, and then eventually it's going to be abandoned and no one is going to think about it. So I think it's also something that we have to make an effort into always keeping it in mind. Also, some Caliber, like I said, one of the tools that we use, it does some automatic monitoring and checks, but it's also a paid tool. And doing something, there are a lot of tools out there that are probably open source tools that you can implement yourself. But again, it's also going back to the idea that in order to do performance right, you also have to spend resources, you have to spend time, and those are very difficult to be given sometimes by given the priorities of the company. So it ultimately means that setting up automatic checks and monitoring can also become difficult. And yeah, that's related to having like reminders for performance. That's part of the next point. Ideally, and one of the things that maybe we should try, we haven't tried it yet, but we would like to try, is to actually make it part of like the checklist of things like of the definition of done or whatever, to say like, hey, is this new feature or is this change, this iteration not hurting performance significantly? Maybe that's also an ideal that we should aim for. I put here because maybe if you're interested, if you're here, hopefully it's because you are actually interested about performance. Maybe then you already know what about this idea of performance budget. Obviously, we can only talk about our own experience, but this is something that we decided not to start with, at least, because it's very tricky to set up. Sorry. So one of the things about it is that you have to think about, okay, what should be the numbers that we should never go above when it comes to the metrics like time to first meaningful pain or time to first byte, stuff like that. But the problem is that there are different you will find different ways that you can set up this theme, but essentially it's always tricky to get started because you might not choose the numbers that represent your current performance, because the moment that you introduce a new feature, you're going to break the budget, right? And
not only a new feature, like if your website is CMS driven, like websites nowadays, I guess. It could also be a matter of someone in our back office adding some more pictures, replacing the pictures on the product page, or adding more. Or for example, on our city page, to add more products. So now it shows 32 products instead of 24 before. So it's ever changing.
Right.
Dynamic.
Right. And I think the most tricky part of the performance budget is that it essentially challenges the idea that before you even put a new feature live, you have to see if it doesn't break your current budget. Because if it does, then in theory, it means that you should roll back this feature. It means that you have to reconsider taking another feature out in order to make space, in order to make budget for the one that you want to introduce. And yeah, realistically, I mean, the times that, not necessarily in Tiqets, but in previous companies where we tried to do performance budgets, the moment that we happen to be breaking the budget this time, it didn't mean anything. It was just like, okay, we need to put this out there, so let's just increase the performance. And then what's the whole point, right? Like, so yeah, I put it there because it's actually something that it's always in the conversation when it's time to start thinking about performance, but I feel like it's, in my experience, not a good starting point, because it's actually very hard to fight against the nature of a product company. So it's not a good place to start from the point of my experience. But yeah, I have to mention it because I do think it's a common thing. And yeah, finally, it's almost over. Future plans. This is something that some of these things we thought about the moment that we won the race. We wanted to, like, okay, let's do these things, but they might be either a bit ambitious, or yeah, we just haven't had the resources again to look into them properly. But some of the things that we think can potentially also bring a lot of performance gains. So we write our code in TypeScript, but for the purpose of supporting older browsers, we have to compile this down to like ECMAScript 5 or whatever.
Microsoft Edge.
Right. But and therefore these bundles tend to be bigger than they necessarily have to be, because modern browsers can actually interpret ECMAScript 6 or maybe even more. So one of the ideas that we want to try is to actually compile down to like a modern version of the JavaScript code and a legacy version. And based on the browser that is requesting it, we serve one or the other. Hopefully, the modern browsers will get a much smaller file size. So that's the goal. The other one is specifically about the pieces of the React that we have in our website, the applications that we have in our website. Some of them might only be needed to be requested and initialized, like request the files that for them to work only when the user actually scrolls to the point of the viewport where they are, or when the user focuses on a particular field or clicks on a particular place. So interaction-based lazy loading. That's also something that we want to do. We're not doing it almost at all. So it's one idea also for the purpose of reducing JavaScript. And on the side of CSS, again, reducing CSS to 0 would be ideal, because it's one of the biggest visual blockers when it comes to loading a website. So yeah, like we mentioned before, almost 80% of Tiqets users are coming from a mobile device. So we also want to experiment with automatically separating the CSS that we write for mobile devices from the CSS that we serve to desktop, because now we're just serving the same for everyone. And maybe this is a good idea. Basically, we're sending to 80% of our users CSS that they will never be able to use because the devices don't even allow it. So the idea here is to actually check what the viewport is and only then request the extra CSS that is needed for bigger viewports. And yeah, also a very common, I guess, technique for reducing CSS payloads is the critical CSS approach. But it's also something that in my experience, it's very tricky to get right. But yeah, we still want to see how we can approach it. The idea here with critical CSS is that we detect the parts of the CSS that is above the folder and take the CSS for those components and include them in the HTML, so the initial server response instead of through a separate CSS file. So the parsing and the loading is not necessary, and we show the content faster. And the rest of the CSS, we loaded asynchronously. So those are like the 4 big winners that we want to consider working on next. That it's all. So,
are there any more questions?
You already asked. So, if I understand correctly, you're saying that there is naturally a backlog of technical debt, and how do we manage to prioritize the performance tasks over the rest of the technical debt? Okay. Right. Okay. Got it. So I guess there's 2 answers, because for the purpose of the race, of course, we obviously wanted to spend more time on that, but that was an extraordinary period. Normally, I can say that from the front-end team point of view, we have essentially 20% of our time. So yeah, I guess if you work 5 days a week, you have 1 day where you can focus on the technical debt, on the backlog of the front-end specific tasks, including performance. So even if some of the performance tasks are not part of like the product development team that you're part of, Tiqets has made this time for us to actually spend fixing this kind of thing. So I guess concretely that's the answer. Yes. Yes. Right. Yeah, that's a very good question. Okay, so for one thing, on a technical side, we're also, because we moved to the CDN that we're using for static assets, one of the things that we have is HTTP2 in order to serve this request. So indeed, there is an extra cost that you have in order to make the second request, but thanks to HTTP2, that cost is much lower, because you already are making a first request to Commons CSS, which is coming from the same domain.
But of course, also how to split those CSS files, it depends. So we looked at our most visited pages, like the home page, city page, product page. It makes sense to have separate CSS files for that. For the checkout, we just assume a happy scenario, checkout, payment confirmation, so that could go in one bundle. The rest is less important.
And The other thing to consider as well is that the behavior, at least when we made the decision, the most common behavior of the users is that you wouldn't actually, like a tickets user wouldn't actually go to 10 different pages in one session. They, like, obviously for the purpose of our funnel, we want them to go from any landing page to checkout. But yeah, effectively, most of the users are only going to 1 or 2 pages. So that was something that we actually could consciously disregard, I guess. So yeah, hopefully.
Yes. Quick. Just sometimes. Yeah, sure, but performance is not like the end goal. It's the performance is more of a byproduct, quality measure of the product we're building. In the end, you know, our users, they just want to check out, buy tickets to the museum and enter the museums. That's the core product. Yeah, so of course it's something that to always keep in mind, but adding new features that company wants and we think will help the user or help improving performance, conversion, it will always come with some cost. So just the fact that the payload will increase will never be a reason to not do this feature. So that's what we meant with this struggle. Kind of challenge, like what kind of contest? Or I'm not sure if I understand your question very well. One for the backend. Well,
oh, you mean like if we actually were responsible for creating a contest on performance? Okay, all right. I feel like one of the things that Google definitely wants to push companies to try is AMP. But yeah, maybe, I don't know why I said that, but basically we shouldn't never consider doing that. But I feel like if I were Google, maybe one of the things that I would try to promote is to build features on the web that make evident that you might not need a native application because the web is enough to do the things that your product requires. So, and I mean, they already are actually kind of doing this effort with progressive web apps, where they try to promote some of the APIs that are available in mostly all the modern browsers, like Service Worker or web workers and stuff like that. Can take care of doing better performing heavyweight applications, and also like offline storage and faster loading times thanks to the Service Worker and stuff like that. So I feel like I would make the effort on like building features that are actually now possible to do on the web, that maybe as developers we're not so aware, that are not exclusively to native applications anymore. So I would try to promote that part of the web if I had the opportunity to do that as Google. Yeah, I think we should go.